Okay, this is problem number 27 from section 1.7. We're trying to find the speed of the current when we're given this information. We know that the motorboat in this problem goes 15 miles per hour in still water. So upstream, this motorboat will be going slower because the current will be pushing against the motorboat. So that would be 15 minus the rate of the current. Downstream, the motorboat will be going faster because the current will be going with the motorboat. So that will go 15 plus the rate of the current. Now, we're also given that this boat goes 10 miles upstream and then 10 miles downstream. And it takes the boat a total of 1.5 hours. So we wanted to find the speed of the current with this given information. With this information, we can come up with or describe the time of upstream plus the time of downstream, and we can set that equal to the total amount of time. We can do that because if we divide this equation, distance equals rate times time, divide both sides by r, then we see that time equals distance over rate. Okay? So let's set up a little chart using this information. Let's go upstream and downstream. And let's go have our distance, our rate, and our time for each one of those. So we know that the distance for each one of those, 10 miles upstream, 10 miles downstream. And the rate for upstream would be 15 miles per hour that the boat was going in still water minus the speed of the current. So we would call that R. Downstream will be 15 miles per hour plus the speed of the current. We'll call that 15 plus R. Therefore, we're going to set this up as time equals distance over rate for each one of those. So time equals distance over rate. So for upstream, we have 10 over 15 minus R. For downstream, we have 10 over 15 plus R. So now, time upstream, 10 over 15 minus R, plus the time downstream, 10 over 15 plus R, equals the total amount of time of 1.5 hours. Now here we would want to clear our denominators out of here. We don't want those variables in our denominator. So we're going to multiply both sides, or multiply everything by the common denominator of 15 minus R times 15 plus R. Alright, so now with this first fraction, the 15 minus R will cancel because I have this in my numerator and my denominator. So I'm left with 10 times 15 plus R. Second fraction, the 15 plus R's will cancel. So I have plus 10 times 15 minus R. Over here, neither one of those would cancel. So let's go ahead and multiply this out using our shortcut of a squared. A plus b times a minus b equals a squared minus b squared. So right here, 15 times 15, or 15 squared, will give us 225 minus r squared. Okay, so distributive property, 150 plus 10r plus 150 minus 10r equals 1.5 times 225 minus r squared. Like terms, we have 10r, positive 10r, negative 10r on this left-hand side. They cancel each other out. 150 plus 150 gives us 300. Okay, let's divide both sides by 1.5 to get that cleared out of there. Then 300 divided by 1.5 gives us 200. Then we have 225 minus r squared. Divide both, or subtract 200 from each side. So now we have 0 equals 225 minus r squared. Now I like to have a negative on my regular number in this situation so we can use the difference of squares. So we can divide everything by -1 or multiply everything by -1 to change those signs around. And that will give us r squared minus 225 equals 0. Now we can use the difference of squares to factor this out. So we have perfect squares, subtraction of two perfect squares, so we can break that up into two binomials. R, the square root of 225 is 15, so R plus, oh I'm sorry, I made a miscalculation there. Let me go back and fix that. This should be 25. Okay, so R plus 5 times R minus 5 equals 0. Set each one of those factors equal to 0. And we see that the rate of the current here is -5. I solve this equation, the rate of the current is +5. Now in this word problem, since we're trying to find the speed of the current, it would only make sense for the speed to be positive and not negative. So my final answer, the speed of that current would be 5 miles per hour. Okay, I hope you found this to be helpful. Thank you.